The author is interested in the relationship between domestic temperature and humidity and the COVID-19 infections in Bangladesh. The scientists argue that higher temperature and humidity decrease the speed of infections for coronavirus. But some of them disagree, since there is not enough evidence to show any connections between temperature and infections. It is a cross-sectional study. The data of daily temperature, humidity, and COVID-19 confirmed cases in a certain time interval is collected. The participants are the individuals who are reported in this experiment. They are either the confirmed cases or the everyday reported cases. In addition, there is a huge number of statistical tests and methods, such as the multiple linear regression, means, standard deviations, and so on. For the multiple linear regression model, there are 3 independent variables, which are temperature, humidity, and reporting tests. It is a method to find the association among these variables. To be more specific, the estimated slopes, beta 1, beta 2, and beta 3, and the estimated intercept, beta 0, are calculated in this process. The slopes reveal the relative change for the y-axis based on the 1-unit change for x values. The purpose of multiple linear regression is to make predictions. The RMSE, which is the root mean squared error, measures the prediction errors. If the RMSE value is relatively small, then it reveals that the prediction is more accurate. In addition, the main idea in this research is divided into 2 parts. The first one is that when it is 26 degrees, the virus has the highest speed of spread. When the humidity is 55%, the coronavirus also has the highest speed of spread. It is the most appropriate temperature and humidity for the virus to spread out. When the temperature and humidity increase on the x-axis, the spread of COVID-19, or in other words, the confirmed cases of COVID-19, is decreasing. The second idea is that when temperature increases by 1 degree, the relative speed of spread decreases by 11.76. When humidity increases by 1%, the speed of spread decreases by 8.79. It is important to build the null hypothesis and the alternative hypothesis. The null hypothesis states that the beta, or the slope, is equal to 0, while the alternative hypothesis states that the beta is not equal to 0. Based on the p-values for the linear regression of average temperature, the p-value is 0.038. It reveals that there is moderate evidence against the null hypothesis. The p-value for humidity is 0.005. It means there is strong evidence against the null hypothesis. Therefore, the slope is different from 0 for both 2 linear regression models, since p-values are less than 0.05. Overall, higher temperature and humidity decrease the spread of the coronavirus. Colder and drier areas provide a better environment for the virus to survive. Also, the immune system does not have good protection owing to the drier environment. Moreover, there are several areas that have to be improved and noticed. It is better to consider more independent variables, since the prediction is more accurate. Secondly, the information between the independent variables and confirmed cases of COVID-19 has to be identical. If the range is the entire country, both information for variables x and y have to be the one in the country rather than the province. And lastly, there is a huge possibility to see the underreported cases since the information system is not very advanced.